What's up everyone? Today we're going to go over Leetcode 665 non-decreasing array. First we'll go over the input and approach, then we'll look at the code and complexity. So the input is going to be an integer array and the output is going to be Boolean true or false. Our job is to take the input and convert it into a non-decreasing array by changing at most one number. Let's look at the examples. If we have an input of 4, 2, and 3, we're going to have an output of true. So 4, 2, and 3 is the input, and we can convert it into a non-decreasing array by changing the 4 into a 2. So we drop the 4 down to a 2. Next, for 4, 2, and 1, the output is going to be false, because even if we change 4 to a 2, we're still going to have a decreasing array because of the 1. So just to be clear, a non-decreasing array is an array such that no number is smaller than the number behind it. Now let's look at the approach and understand a few different cases. I've drawn it not using numbers, but instead of steps so you can visualize it better. Here's a valid non-decreasing array. If the values of the numbers are the same, that's valid. If the values increase, that's valid. But anytime a value or a step is smaller or lower than the number behind it, we don't have a non-decreasing array. So what should we do? Should we move this up or should we move this down? Let's look at it with a few different cases. Here's an array. We have black, then we have green, it increases, and then we have blue, which decreases. So that's a problem. Blue is going to cause us to have a decreasing array. Now, should we move the green down or should we move the blue up? In this case, we can't move the green down because even though that would fix the blue and the green relationship, the black is going to give us a decreasing array. So we have to move the blue up. The reason we had to move blue up is because blue is smaller than black. Let's look at it. So here on the path, if we try moving green down, these two are the same, but black is higher than both of them. So that's invalid. Because we can move also blue up, green and blue are valid, and black is also valid. In the previous case, we had to move blue up because blue was smaller than black. What happens if black is smaller than blue? Do we move the green down or do we move the blue up? Because both of them seem right. This one going down here, this is valid. And this one going up here, this is valid. So which one do we pick? Good question. We are going to go with moving the green down. That's because we don't know what number we'll encounter later in the array. If we had a number here, this case would be valid, but this case would be invalid. So for the safety of not knowing what numbers we're going to encounter in the future, we're going to pick the number to be smaller. So we're going to move green down. I've written the code and I put the colored dashes next to the parts in the code. First, we initialize a count variable because keep in mind, we can take our input array and modify it at most once so that it transforms into a non-decreasing array. Next, we begin iterating. And anytime we see a number which is smaller than the number behind it, we're going to try doing some modifications. If we're just starting out, or if ARR of I minus 2 is less than or equal to ARR of I, so if black is less than or equal to blue, then we are going to set ARR of I minus 1 equal to ARR of I. So we're moving green down. Otherwise, we're going to set ARR of I equal to ARR of I minus 1, and we'll be moving blue up. In both cases, count is going to be incremented, and we're going to see if count is less than or equal to 1 to return a Boolean value. The time complexity is going to be big O of n because we're iterating through the entire array once. The space complexity is going to be O of 1 because we're not using any additional structures. So that's how you solve non-decreasing array. Let me know what you think in the comments below. And if you want to see more, don't forget to subscribe.